Figure 1 shows part of the curve with the equation y equals f of x for x belonging to R. The curve passes through the points Q and P as shown. Find the value of ff of minus 3. On separate diagrams, sketch the curve with equation y equals f to the minus 1 of x, y equals f of modulus x minus 2, y equals 2 f of half of x. Indicate clearly on each sketch the coordinates of the points at which the curve crosses or meets the axes. Okay, so I'm going to do small sketches because I've got a digital pen. So first of all, ff minus 3 is now. So this is equal to, so let's just write it here, f of 3. F of minus 3 is now. F of minus 3, input is here, output is here, 0, so it's f of 0. Input is 0, output is 2, so it's equal to 2. Sketch y equals f to the minus 1. Well, I'm going to draw a small axis here, say, and do this one here then. Here's the axes. So let's have a quick go at this. Y, x, and 0. Just move the axes up so that it looks a bit better. Yep, just move it to there. And then, okay, and then we're going to move this. I'm going to copy it so we can use it a few times. Okay, so here's our sketch then. So basically in our mind's eye we have to pull this off the page and twist it over so that this axis here becomes vertical and the y-axis becomes horizontal. So I can pull it off the page and hopefully you can see in your mind's eye that the curve's going to, when it does that, when you swap the axes over, pull it off the page and switch it round, it's going to look like this. Yeah? This point here is this point here, so this is P minus 3, so this would be 0 minus 3, wouldn't it? And this point here would be 2 naught, Q is 2 naught, and these are just the points P and Q, so we'll call them P dashed and Q dashed. Okay, and that was A. And this is y equals f to the minus 1. And basically all we did was we pulled this off the page and then twisted it over so that this axis pulled it off the page, twisted it over, became here, and the y-axis twisted off, pulled over, became there, and then we swapped the symbols. The y became an x-axis, the x became y. And that's the process. So that's that sketch. F of modulus x then, let's have a look at this one. Here. Now we'll do B. We've done B. That was B. Now we'll do C here. So a little sketch here for C with the digital pen. F of modulus of x minus 2. Well, here's the value of x, isn't it? And when x is positive, this will be none other than f of x's. So these are the same. But instead of these values, this curve here, it would be shifted down vertically 2 units, so it would come from the axes and go like that, wouldn't it? So it's going to come out from the axes and go like that. And that's for the positive values. And this was, we'll call this Q dash dashed, 0, 0 here. And then basically, if we put a minus x value in here, say minus 3, it would be f of 3. F of 3 would be here, take 2, would correspond to this value. So it's symmetrical, isn't it, about the y-axis? So it's the same the other side. So it reproduces this curve here on the other side. So this is the curve then, for C. Now we want D. So let's move this down and we'll do D now. Here. So 2f to the minus a half of x. Okay, put it in here. So we've got some room. So 2f to the minus a half, 2 lots of f to the half of x. So basically, if you think about it, when you put in 2, the value 2 for x, you get f of 1. So the value that was here stretches out to here. So the height, so it stretches out, it's a lot flatter. So this would be here. If we put, say, minus 6 in here, we get f of minus 3, which is 0. So that stretches out to there. And we're 2 lots off, so it's going to go up. So it's going to stretch out and go higher by a factor of 2. So the value here is minus 6, 0. And we'll call this p triple dashed. And that's that. And then the 2 value, 0 would be the same. F x is 0, you get f of 0 is 2. And it will go up to 4. So it's the curve here. And it's just going to go like so, isn't it? Oops. So that's the curve. And there's the crossing points. And this would be 0, 4. And we'll call this q triple dashed if we want. And that's the curve here. So y equals 2 lots of f to the half x.